going to go ahead and get started since it is 11. That clock is slow. It really is 11. So today we are going to do 2.2. So last night at midnight, you should have had 2 assignments that were due. The 2.1 and the course agreement. Okay? If you're still having issues finding out where to do your assignments or you didn't get it done last night, shoot me an email or let me know or whatever. And I need to just make sure everybody is comfortable on the flow of the class. Now, another thing is, and I know from my 9 o'clock class that the attachment didn't come attached to what I thought was going to send this morning. So I'll have to send it another way. So at the beginning of the week, what I'll do is I will send you the handouts that I am going to go over for the whole week. You can print them off. You don't have to, whatever. I just can't put them in Blackboard anymore. So now what's going to be in your Blackboard weekly folder will just be YouTube videos. Okay. So I'm live streaming right now to the people at home and the people in here. After I live stream this, I will convert it into a YouTube video. And then I'll put the YouTube video in your week 2 folder that's in Blackboard now. Okay. So 2.2. This section is more on functions and graphs. The first thing that we're going to talk about that's going to go with the first 4 problems is what the definition of a function is. What makes a relationship a function or not? Okay. A relationship in which each element in the domain, and the domain is the x values of your relationship, only corresponds to one element in the range, and the range are your y values. Okay, so again, each element in the domain only goes to one element in the range. So let's look at a couple of these. Like number 1. So this is going to be like number 1 in your homework. Hey, come on in. Good. How are you? College Algebra? Yeah. What's your name?
Brian.
I'm sorry. Say it again.
Yeah, Brian.
Oh yeah. Come on in. Okay. So number 1 will look like this. It's going to have a column for domain values. And a column for range values. And it's going to ask you if this relationship is a function or not. Come on in, college algebra, right? You're good. Just find one of these with the, I forgot, this is a heavy Monday class, which is fine. So the values in my domain column are 10, 6, and 24. The values in my range column are 25 and 21. And then each one in the domain has an arrow coming out of it. The 10 has an arrow going to the 25. So what that is showing is, what is this element in the domain going to? How many numbers does it go to? Just 1, right? Which means we're still a function. You're only a function if one of your numbers in your domain goes to 2 numbers in your range or more. More than 1. Okay? Now, it also shows the 6 with an arrow to the 21. So, still a function because 6 is only going to 1 number. It's not going to any more than that. And then the 24 also goes to 25. How many numbers is 24 going to? Just 1 again. There is not any number in the domain column that is going to more than 1 number in the range. So that's why, yes, this is a function. This is what it would look like if it was not a function. It would have one of these numbers, we'll just say 24 is going to 25. 21. That's what would make it not a function. If one of the numbers in the domain had 2 arrows coming out of it going to 2 different numbers in the range. So see the difference? So since none of the numbers went to 2 different numbers, that's why, yes, this is a function. The first 4 problems are like this. Right? Number 2, same kind of problem. The domain numbers are -1, 4, and 8. The only number in the range is 2. Now, remember, don't get it backwards. How many numbers does -1 go to? 1. How many numbers does 4 go to? 1. How many numbers does 8 go to? 1. Is there anything in the domain that went to more than 1 number in the range? No, there's not. There's not even more than 1 number. There's only 1 number in the range, which means that would be impossible, right? For any of these to go to more than 1 number. So yes, this one is a function. Why is it a function? Because this one is multiple choice. It's gonna have 2 yes options. And then it's going to flip-flop the words domain and range. So what makes it a function? Because, yes, it is a function because each element of the domain only goes to 1 element in the range. Number 3. Same thing. The domain numbers are 64, 125, and 8. My range numbers are -4, -5, -2. So, depending on where my arrows go, this may not be a function because if one of these numbers has 2 arrows going out of it to 2 different numbers in the range, that makes it not a function, okay? But it doesn't. 64 goes to -4. 125 only goes to -5, and 8 only goes to -2. So yes, again, this one is a function. All right. Last one like this. This time my domain, it's not going to give me numbers, it's going to give me the names of 2 different cities. Chicago and New York. And it's going to give me these, in the range, it's going to give me some sports teams. Bears, Bulls, and Cubs. And Knicks, Mets, Giants. So, Chicago goes to Bears, Bulls, and Cubs. Right? Those are all in Chicago. New York has the Knicks, the Mets, and the Giants. So again, it just wants you to become more familiar with the definition of a function. A function only occurs if each element in the domain, it doesn't matter what it is in the domain, it can only travel to 1 element in the range. So my first element in the domain of this problem is Chicago. Where does Chicago go to? Bears, Bulls, and Cubs. Is Chicago, which is the domain number, going to more than one element in the range. Yeah, it's going to 3 different things in the range. That's what makes it not a function, right? This one is not a function. Because each element in the domain goes to multiple elements in the range. All right, the next 5 problems, it's going to give us a function. And then it's going to say, what happens if you replace the x in this function with something different? What happens to that function? Okay, you've probably done this before. We actually did it a little bit before we started making tables on our calculator last week. We did this by hand a couple of times. Like on number 5, it has a function, and it's calling the function k of x equals x plus 7. This is going to be kind of like 5 problems in one. The first thing it's going to ask me to do is find what's called k of 0. So all you're going to do every single time is whatever is in here. What did this replace from here to here? It replaced the x, right? Mm-hmm. Which means we're going to replace the x in the function with whatever number is in those parentheses and then do the math. So what am I going to replace the x with first? 0. Here's my function. I'm going to use it over and over and over. So I'm going to put a 0 in place of that x, bring down my plus 7, and then do the math. 0 plus 7 gives me 7. So k of 0 equals 7. So what did 0 do to my function? It turned it into a 7. And we'll do it again. This was a different number. This time, what are you going to replace the x in that same function? What are you going to replace it with? Negative 15. So everything's going to look the same with a plus 7 on the end. So I'm just replacing the x with negative 15, bring down my plus 7, okay? If adding, subtracting, multiplying, dividing with positives and negatives is not your thing, punch it in your calculator, right? You spent a lot of money on this calculator. Let's make it worth it. I'm going to talk about that in a second. Negative 15 plus 7 gives me negative 8. Now, I'm not sure if everybody has a calculator yet, but we will use this TI-84 Plus all the time. I will tell you this. If you have like from high school or something, a TI-83, it's fine. Or a TI-84 that doesn't say plus, it's fine. It's going to do everything we do. If you do not have the calculator, there is a TI-84 app that you can get on your phone. It's called, I think there's more than one. The one that I have is called Calculator X. And if you'll see, I mean, it actually puts the TI-84 on your phone. Okay, so you can use that if you want. It's not as user-friendly just because it's, you know, I don't think, maybe I'm just not used to it. But this is a lot more user-friendly. But the app has all the buttons that the calculator does. Okay. All right, the next part of this one says to find k of negative 4. Same thing, replace the x with negative 4. So negative 4 plus 7, then do the math. Negative 4 plus 7 gives me 3. K of 15, nothing new, replace the x with 15. So 15 plus 7 gives me 22. Now, this last part of it is a little bit different. It wants me to find k of x plus 18. So it gives you so many of these so that you just get used to the routine. What's the routine telling me to do? Whatever is inside here, if it's a picture of an apple or the drawing of a house or a -7 or a 0, what are you doing with, doesn't matter what it is, what are you doing with what's in here? Putting that in the x spot, replacing the x with it. So that's exactly what I'm going to do this time. Instead of x right here, what am I going to put in its place? X plus 18. It doesn't matter what it is. Whatever is in here is what you replace the x with. So instead of x, I write x plus 18 because that's what's in here. I still drop down to plus 7. Now this one does have a little bit of work to do because they have what's called those like terms, right? You can put the 18 and the 7 together, right? Those are like terms. There's no reason to write these two numbers separately when you can just really call that 25, right? Because that's what 18 and 7 is. It's 25. So I still have this x. All I'm doing for this math part is putting the 18 and the 7 together. I still have x, and I just put the 18 and the 7 together to get plus 25. Okay, so that's what number 5 looks like. Number 6 is the same kind of problem. It's just going to give me a different function. This time my function is h of w equals 9w plus 9. So just a new function. Let's see, the first thing it wants me to find is h of 1. So again, the letters have changed and everything. The routine is the same, right? Math is just routine, learning routines. So I'm going to replace this w with whatever's in the parentheses and then do the math. So I'm replacing the w with 1 this time. So I'll have 9 times 1 plus 9. Nine times 1 gives me 9. Bring down the plus 9 to get 18. So again, plugging in, do the math. The second part of number 6 says find h of -8. So same thing. Here's what I'm replacing. I'm going to replace it with whatever's in here. So I'm replacing it with -8. So I have 9 times -8 plus 9. Nine times -8 gives me -72. Bring down the plus 9. Again, remember, you don't want to be able to do the routine and know the steps and all that and then mess up right here. If this is not your thing, that's what your calculator's for. Okay? So -72 plus 9 gives me -63. Here's another reason that we have calculators. The last part of this one says to find h of 6.7. So So again, doesn't matter what's in here. That's what you're putting in place of this W. So I have 9 times, I'm replacing the W with 6.7. Bring down my plus 9. And then do the math. Again, I don't want to write this out, right? I don't want to do this work. So I'm just going to punch 9. Uh-oh, hang on. My battery's up. It doesn't give me much warning. So what is that? 9 times 6.7 gives me 60.3. Bring down my plus 9 and then add it together to get 69.3. Okay? All right, number 7 is the same kind of problem. It's going to throw in an absolute value bar symbol. The function is f of x equals the absolute value of x minus 2. Okay, so most people remember, or they just know that when you have an absolute value of a number, whenever you bring that number out, it just turns positive, right? The absolute value of -7 is 7. The absolute value of 7 is also 7. The absolute value is just going to turn you positive. Here's why. The definition of absolute value just means how many spaces away from 0 are you? That's what the absolute value means. So that's why the absolute value of a negative number ends up being a positive answer, right? Because how many spaces away from 0 is -7? It's still 7 spaces away. It's just 7 spaces to this side of 0 instead of that side. But it's still 7 spaces away. So that's why absolute values always, even if they're negative on the inside of the absolute value symbol, when you bring them out, they turn positive. Okay? So the first, we don't even have any negatives. First thing we're going to find is f of 2. So, just like the other problems, again, getting used to the steps, replacing the x with 2. So I have the absolute value of 2, bring down the -2. So when I bring this out, what is the absolute value of 2? Or in other words, how many spaces away from 0 is the number 2? It's 2 spaces away. So this comes out as a 2. That just comes down. And then do the math. 2 minus 2 gives me 0. All right, the second one says to find f of 4. Same thing. I'm going to replace that x with a 4. So the absolute value of 4 minus 2. The absolute value of 4 is 4. Bring down my -2 and then do the math straight across. 4 minus 2 gives me 2. Here's a curveball on this one. The last part says find f of a plus 2. I'm trying to, there's a glare on this. I'm trying to work around it. So just like all the other problems, I'm going to replace the x in the function with whatever's in here. I don't care if it's a rainbow. You're just going to put it in place of the x. So what am I going to put in place of this x inside these absolute value symbols? A plus 2. So I'll have open Replace that with a plus 2. Bring down my minus 2. Here's the curveball in this one. I don't know what a is, right? Which means I can't pull anything out of that absolute value symbol because I don't know what it's going to be. Because I don't know what the a is. I don't know if a is a 3 or a negative 76. Okay? I don't know what it is, which means I just can't simplify this any further than it is right now. I can't bring anything out of the absolute value symbol. So that is essentially your answer. This right here, absolute value of a plus 2 minus 2. I can't do anything else to that. All right, last one like this. The last thing, and I'm going to actually kind of show you a shortcut on this too. The last function on number 8 is f of x equals x to the 3rd power. And it wants me to find 6 different things. So first of all, let's talk about what raising something to the 3rd power means. What does that mean you're going to do to whatever you put in place of that x? What are you going to do to it? Multiply it by itself 3 times. That's what that exponent's telling me to do. Whatever that x is going to turn into, when I do the math, I'm going to multiply that number times itself 3 times. Okay? So when I replace it with 0, I'll just have 0 to the 3rd, which means 0 times 0 times 0, which is still 0. So I replace it with -1. I'll have -1 to the 3rd power, which means -1 times -1 times -1, again, happens to be -1. 3 to the 3rd, which means 3 times 3 times 3, which gives you 27. 10 to the 3rd. Let's see, 10 times 10 is 100, times 10 one more time. 100 times 10 gives me 1,000. Down here to -2 to the 3rd. Let's see, -2 times -2 is +4. +4 times -2, right? Because you got to do it 3 times, gives you -8. Now, this last one, f of -3a. I'm going to physically write this one out. So this means if I replace it, I'll have -3a to the 3rd power, which is telling me to multiply -3a times itself. Right? That's what -3a to the 3rd power looks like if you wrote it all the way out. So let's just do the number part first. Let's see. -3 times -3 is +9. +9 times -3 again would give me -27. What about the a's though? I still have a times a times a. What do you get when you multiply a times itself 3 times? A to the 3rd power. Good. So 27a to the 3rd. Okay, let's find a shortcut that would actually, this one wasn't too bad because all you had to do when you replace the x with different numbers for the math part was multiply whatever you put in that spot together 3 times. But what if this said, what if the function was like that, and you had to find f of 0, f of -1, f of 3. You'd be going through replacing all of these x's with whatever the number in parentheses was, and then having to do a bunch of math. What if there was a shortcut? Go to, on your calculator, hit your y equals button, which is the very top, very left button. Turn it on first. All right, mine still has some math in there from last class, so I'm just going to hit clear. Whatever your function is, put that in your y equals. So I need to hit the x and then to the 3rd power. Remember, your x button is this one right here. It's got that x, t, and a couple other symbols. So that's what will give you your x. To the 3rd power, okay? Anytime you want to go up into an exponent on your calculator, see that button that looks like this? It goes, that means put me up in the exponent. Okay? It is right below your clear button. So that puts your cursor, when I hit it, watch my cursor, it goes straight up into the exponent. And then type in whatever your exponent is. In this case, it's 3. So now I'm going to make a table that shows what my answers are. I'm going to hit the blue 2nd button. And then I'm going to hit the graph button, because if you'll notice right above the graph wording, it says table. So here's what it gives me. Look at your x's. So what you're looking for are these numbers in your x column, because what you just told your calculator to do is to cube all those numbers. That's what, when you went to the y equals and you said x to the 3rd power, what you're telling it to do is every number, put it to the 3rd power. So when I go in my x column and I find 0, so again, I'm going to just scroll it down to the 0 in the x. 0 to the 3rd is what's in your y column, which is 0. If I find, go to the -1 in your x, so I'm just going to go up 1 to -1. The y column is doing to the x what you put in that y equals button, which means it's saying x, it's raising it to the 3rd power, which is -1. Same thing here. Let's go down to 10. F of 10. So go scroll down into the x column until you see the 10. So there's my 10 in the x column. Look what it is in the y column, because what is your y column telling it to do? It's saying whatever number is in the x, raise it to the 3rd power. That's why your y column says 1,000. So that's what you can do. You know, this math wasn't too bad. But again, if we got into a function like that, there's more of a chance of you just making a simple mistake than actually knowing what the rules and the steps are. So we're going to use this table function a lot in this class. You will get very familiar with that table function, especially when you're graphing. Okay? So we'll come back to that table function here in just a minute. Let's go to number 9. So again, this will match when you go in to do your homework in math lab tonight or whenever you do it. When I say number 9, that is going to match your number 9. It's just going to, you're just going to have a different number. The steps to solving number 9 on your homework are going to be the same thing as the steps I'm doing on this number 9. You're just going to use your numbers instead of mine. Okay? So number 9 is a real-world application of turning Celsius degrees into Fahrenheit, right? Because when somebody tells me what degree it is Celsius, I have no, it means pretty much nothing to me because I don't know what that, if that's hot or cold, what, okay? Because we're so used to Fahrenheit. This is what we use. So say somebody told you what the degree was in Celsius, but you're like, oh, I need to figure out what that is in Fahrenheit before I decide if I need a jacket or not. Okay, so let's see. The function for that to occur is this. F of C equals 9/5 times, not that, 9/5 C plus 32. Which means if somebody tells me a Celsius degree, I can plug it in for this C, do the math, and then I'll know what the Fahrenheit equivalent of that is. Okay, so this problem says to find the Fahrenheit equivalent to 25 degrees Celsius. So the way that translates into what we've been doing with all that plugging in for X is what I'm actually finding is F of 25. Right? The Celsius number is 25. Which means I'm going to replace the Celsius in this formula with 25. Okay, the other beautiful thing about this calculator is it will do all of this math for me. I don't have to even know how to multiply fractions anymore or add them with unlike denominators. If we ever have to do that, right? That's what the road trips everybody up is adding fractions with unlike denominators. We don't have to know how to do that anymore, okay? My opinion on calculators is if it didn't happen for you in K through 12, I'm not going to try to teach you how to add fractions with unlike denominators in college. Okay, if it didn't happen then, I'm not going to work any magic to make it happen now. Okay, but I can show you how to do it in the calculator. So, what do I want to tell my calculator? I'm going to type it in exactly like I see it right here. I need to know what 9/5 times 25 plus 32 is. Tell your calculator exactly that. So to type in 9/5, you'll just do 9. To make the fraction bar, you hit the division button. So 9/5. Now, you can either type in the times symbol or exactly what this is showing right here. Open parentheses, 25, close. Either way is telling your calculator to multiply that times 25. So I'm just going to type it in exactly like I see it here. I'm going to do open parentheses, which is right above your 8, 25, close, plus 32. Enter. So it does all that math for me. What did it tell you? It gave you 77. So 9/5 times 25 plus 32 gives me 77. So when it's 25 degrees Celsius, it is 77 degrees Fahrenheit. Okay? Now, the next several problems, we're going to use that table function because the next several problems, it's going to give me a function, and then it's going to give me a chart to fill out, and then it's going to ask me to graph it. Okay, so let's go look at number 10. It says graph the function f of x equals negative 2x plus 2. So it gives me this function and it says to graph it, but it says before you graph it, fill out this chart. So So what's occurring here is these numbers right here are missing. So what this chart creates are points that lie on whatever this is. Whether it's a line, a circle, a U, a V, or whatever. You can always fall back to making an X, Y chart. And f of X and Y mean the same exact thing. They both mean this column is a function of whatever this is, which means this number is what it is because that's what you get when you replace the X with the X number. So what am I going to replace the X with first? -2. So I can do that over and over and over, or I can go to my Y equals in my calculator, which is what I'll do. So I'll just clear it out. I'll go back to my Y equals and clear it out because I still have my X cubed in there from last time. And type in whatever my function is right here. -2x plus 2. Remember, your negative button is the one below the 3. So -2, this button right here is your x plus 2. Now, I am going to graph it in MathLab. So let's go ahead and just hit the graph button, because that way you'll know what's about to occur. Because remember, when you are graphing in MathLab, if you've done your 2.1 homework, before you start plotting points, you have to go over in that palette and tell it what shape you're about to draw. Whether you're going to draw a line, or the U, or the V, or that squiggle thing. So how am I going to know that unless I'm familiar with this, unless I see it with my own 2 eyes? I can see that I'm drawing a line. So after you tell MathLab that you're going to draw the line, then it's going to ask you to plot 2 of the points on the line, which is where this chart comes into play. Now, so I don't have to do over and over replacing the X with these. I'm now going to tell my calculator to do that by hitting the second button and then hitting the graph button again, because once you see right above the graph wording is the word table. So what it does is it makes this table for me. So to fill in these missing things, I just need to find these numbers in my X column and then put the Y that goes with it. Because what have I told my calculator to do? I've told it to any number that it puts in for X to multiply it times -2 and then add 2 to it. That's what you told the Y equals to do. So now when I come looking at my table, I need to find where X is -2. So I need to go up past 0. There's -1. There's -2, which means what's the Y or f of X? They mean the same thing. That goes with it? 6, right? So it did the math for me. It put the -2 in here and then did -2 times -2 is 4 plus 2 is 6. So I plug in 0. Again, I just come in and look for my X number to be 0 and then put the number that goes with it, which is 2, here. Same thing. Go to my X column, look for 2. There's my 2. The number that goes with that is -2. So again, once you get used to that table function, you're not ever going to come back and say, you know what, I think I'd rather just do all that myself. You're not ever going to want to do that again, right? That's what the table function is going to do for you. Yeah. Right. Yeah. Yes, definitely. So the way that what makes the graph be the shape that it is going to be is what's happening with the X. If it's just an x, not an x squared or an x to the third, if there's not absolute value symbols around the x, if it's just an x, it's going to be a line. It's called a linear function. If this would have been x to the second power, if you're looking at a graph and you're looking at it before you even hit the word graph in your calculator, if it's to the second power and that 2 is the highest exponent that you see, it's going to be a u. Different things happening to the x make it be different shapes. This is called linear. If it's just an x with no exponent or absolute value or x is not in your denominator, anything like that, it's going to be a line. It's called a linear function. Now, after you see that, then you're going to go and plot those points to draw that line in math lab. Okay? All right, let's do one more, number 11, and then we'll finish this up on Wednesday before we do 2.3. Okay? Number 11, the function is f of x equals 3 minus the absolute value of x. Again, it gives me a chart. It tells me the x's it wants me to use, -2, -1, 0, 1, and 2. So this one's not going to be a line. It's going to be something else. Okay, and we'll kind of become more familiar with these once we get through. But if your x is in an absolute value, your shape is going to be a V. It might be upside down V, but it's going to be a V. So what do I need? I need to go to, and I want to point this out. So you're going to go to your calculator, go to your y equals again, because I don't want to do all the math on my own. Clear it out. And I want to type in 3 minus the absolute value of x. So 3 minus, and we did this once, I can't remember what day last week, but absolute value, you're going to find that by hitting the math button. Once you hit the math, you're going to go to use your right arrow one time to go over to number. The first function under number is absolute value. It'll say ABS. So hit enter, because that's what's highlighted, right? Is the highlighted on the ABS. So hit enter. When you hit enter, look, it gives you those absolute value symbols in your y equals. So you'll just put the x in there. And again, since I am going to graph it here in a minute, let's see what it's going to look like. There's my V. It's just upside down. But for now, I just need to be able to fill out my chart. How do you make the table? Second graph. There's your table. Find the x's that you need so that you can put in the y's. So let's see. -2 gives me 1. -1 goes with 2. 0 goes with 3. 1 goes with 2. 2 goes with 1. And then you'll plot those points to draw that upside down V. Okay? All right, let me take roll. All right. All right, Keon Bryant. Maggie Davis. I see you, Maggie, online. Jason Dickey. Abby George. Mariah Gant. Last name Gongor, Gongor. All right, Tabitha, I see you. Faith Montgomery, not here. Cole Outlaw, got you. Gabriella, not here. DeCavion Ramsey, got you. Paul Reeves, got you. Clayton, Washak is here. And Bailey Ledoux, I see you. All right, anybody's name I didn't call? Did you just add late?
I just enrolled on Friday.
Okay, yeah, I printed this off before that. What's your last name?
Marshall.
Marshall, what's your first name? B-E-V-Y-N. Okay. Okay, I will see y'all either on campus or Zoom on